Hello and welcome. In this presentation, we are going to look at calculating the perimeter of some standard and some composite shapes. As you are probably aware, perimeter is about working with distance. The standard unit of distance is a meter, and quite often we need to convert distances between meters and kilometers, or meters and centimeters, or millimeters. And if I need to convert a value from a kilometer to a meter, I will multiply that value by 1,000. So for instance, 1 kilometer equals 1,000 meters. Likewise, if I wanted to convert from a meter to a centimeter, I would need to multiply by 100. So for instance, 5 meters equals 500 centimeters, and so on. A centimeter to a meter, I multiply by 10. And if I need to go back the other way, millimeters to centimeters, I will divide by 10, 100, or 1,000. If, for instance, I wanted to convert a kilometer to a millimeter, I would multiply by 1,000, and then multiply by another 100, and then multiply by another 10. Now, perimeter is about the distance around shapes. So this is probably as good a definition as you'll see. The perimeter is the distance all the way around the outside of a two-dimensional shape. Here are some of the standard shapes we would work with. A square, the perimeter is effectively 4 times the length of one side. That is because all 4 sides have the same length in a square. The perimeter for a rectangle is 2 times the length plus 2 times the width. 2L plus 2W, or if you wish to factorize that expression, 2 times the length plus the width. These are the standard formulas for triangles. It's effectively the length around all 3 sides. Equilateral triangle will just be 3 times S. Isosceles, 2 times the A plus the length of the B of the base there. And a scalene, where all 3 sides are different, A plus B plus C. Again, it's just the length around our two-dimensional shape. Circle. Well, the name of perimeter in a circle has been replaced by the word circumference. It is the distance around a circle. That is, its perimeter. It is given with the formula circumference equals pi multiplied by d. Now, pi is a letter from the Greek alphabet. It's typically a button on your calculator. If you have a look, you'll be able to see that. And it is approximately the value 3.14. It's an irrational number in that it will keep going on forever after that decimal point. And this can also, formula is quite commonly identified as the circumference equals 2 times pi times r. This is the formula I prefer to work with, but it's quite okay to work with the circumference equals pi times d. Another way of thinking about this, the radius, the distance from the center to the outside, is 1/2 the distance of the diameter, which is the distance from side to side going through the center of the circle. If I'm working with an arc, you'll see this here, that red section there is my arc. It's basically, I need to work with the perimeter of a full circle, which is 2 times pi times r. And then I know this is a fraction of a circle. And what fraction is it? Well, it is theta, because that is the angle, divided by 360, because there are 360 degrees in a full circle. Whoops. And we'll just move on to the next shape. We've got a few examples happening now. Look at the perimeter of this square. Well, we can say one side length is 4, then it's 3, one side length is 3, then it'll be 4 times 3. In other words, 3 plus 3 plus 3 plus 3. That is the distance all the way around my shape. Example 2, a rectangle this time, a length of 8, a width of 4. So in other words, the perimeter would be these two 8s plus that 4, and whoops, that's 4 over here. Well, let's look at this triangle. Well, I have length of 4 for the base. This side here is 8, and this side here will also be 8, because this little sign here just indicates that this side is the same as that side there. So 4 plus 8 multiplied by 2, 20 meters. Next example, calculate the circumference of this circle. Well, circumference of the circle is 2 multiplied by pi multiplied by r. Substitute those numbers into the equation. Well, radius equals 3, that's my r, and I would get pi from my calculator, so I'd end up with 18.84 meters if I was writing this to 2 decimal places. Now, this one here, calculate the perimeter of this quadrant. Now, a quadrant is the name that we give to a quarter of a circle. It can also be any shape or slice of a pizza, or pizza slice, if you wish, is called a sector. A sector is just, a quadrant is just a sector that happens to be of 90 degrees. Now I need to work out the distance all the way around this shape. So I know that I have 5 meters here, and because it is a circular shape, I will have 5 meters here. So all I need to do now is work out the distance of this shape, this part here, this arc. So it'll be 1/4 of a full circle. There is my fraction, 1/4 of a full circle. 2 pi r is a full circle. So it's a quarter multiplied by 2 times 2 times pi times 5. 7.85 meters. And what I need to do is add up each part of this figure, the distance that I need to travel to get around this figure. 5 plus the 5 plus the 7.85. And there you have it, my answer, 17.85. Next example, calculate the perimeter of a semicircle which has a diameter of 12. Now, a diameter of 12, well, what is the radius? Well, the radius would be 6 meters. It is half a diameter. So I know if I have to go all the way around this shape, there's my 12 I just need to calculate this part here. So it is half a circle. Perimeter of a full circle, 2 times pi times r. And I have half a circle, so that's where the half comes from. Half times 2 times pi times 6. I need to use 6 because 6 is my radius. Equals 18.84. So my answer would be the 18.84, which is this part here, plus the 12, which is that part there. Just a couple more examples. This looks a bit like an ice cream cone. Wish to calculate the perimeter of this shape. In other words, I want to walk all from here to here, around here, and back there again. So I'll start here with 10. Now I'd also this side here is 10. And I would know that this distance around here I could calculate. It is half a circle with a radius of 5. Well, it's 10 all the way from here to here. You've been given this with this little symbol here. So from here to here, which would be the radius of 5. So I have half a circle multiplied by 2 times pi times my radius of 5. Half multiplied by 2 times pi times 5 gives me this number here. And the answer I'll be looking for would be 35.7. In other words, I would have to walk 10 plus another 10 meters plus 15.7 to get around there. When I add all those up, 35.7. And last one, calculate the perimeter of this compound shape. Well, if you have a quick look and just think about this for a second, there are 3 semicircles here. There is a semicircle here. There is a semicircle here. And there is a semicircle there. I need to calculate the perimeter of each one of these semicircles individually, then add those together, and that will give me the perimeter of this composite shape. Just remembering, the perimeter of a semicircle was half the perimeter of a full circle. That's what we're working with. Full circle, 2 pi r. We have half of that distance. So I'll leave that there. So this bit up here, 2 pi times 10. Well, if you see it's 20 from here to here, the radius will be 10. That will give you that component there. I need to add to it this component here. The radius this time will be 5. In other words, 5 from the center going to the outside. 2 times pi times 5, and I need just half of a, that would give me a full circle of radius 5. I just want half a circle. And the last one, this, the largest of the semicircles. This time, the radius would be 15. Well, it's 30 all the way from there to there. Half of that would be 15. So half of 2 times pi times 15 gives me this here. So if I needed to go all the way around that shape, I would add up each of the individual journeys, which gives me 94.2 meters. Well, there you have it. I hope this presentation has given you a much better understanding of some of the basic rules for calculating the perimeter and how these can be combined together to calculate the perimeter of composite shapes. So, until next time, good maths.